In this video, we're going to talk through the worked out solutions to the 7A6 warm-up. When I look at number 1, the directions say solve the equation. I know when it says solve the equation, my answer is going to look like x equals, y equals, whatever variable that we're using equals. So when I look at this, I'm trying to figure out what could x be to satisfy this equation. My first step will be to isolate what's being squared. So we have only x being squared. So I'm going to subtract 3 from both sides. I have 200 is equal to 4x squared. I still have not isolated what is being squared. So I'm going to divide by 4 to do the inverse operation. 4 divided by 4 is 1, so I'm just left with x squared. 200 divided by 4 is 50. And now I need to solve for x. Well, when I look at this, 50 is not a perfect square. So if I take the square root of both sides, I'm going to have an irrational answer as my solution. We're going to get x is equal to the square root of 50 or the negative square root of 50, because it could be the positive or negative root. On your quiz, you want to make sure that you are writing your answers in simplified radical form. The decimal approximation would be if I type in square root of 50, I would get it's approximately 7.07. So x is approximately plus or minus 7.07. Again, this is the approximate answer. But I want your simplified radical form. So I want the exact answer in simplified radical form. To do that, we take square root of 50, and I'm trying to think what perfect square is a factor of 50. So when I think about the factors of 50, I know 1 times 50 is 50, 2 times 25 is 50, 5 times 10 is 50, and I can't think of anything else. So when I look at all these factors, both 1 and 25 are perfect squares. However, if I break this apart into square root of 1 times square root of 50, I'll be left with the same answer. So I'm not going to focus on that. I'm going to use these factors to break apart 50. So I'll say that this is really square root of 25 times square root of 2. Square root of 25 is 5. Square root of 2 is irrational because 2 is not a perfect square, so this remains square root of 2. So my exact answer would be x equals plus or minus 5 root 2. So again, this is your exact answer, or another way to say this is simplified radical form. So simplified radical form. This is the answer I'll be looking for on a quiz or test. Scooching up here to number 2. Number 2 says, find x when f of x equals negative 487. Well, I'm finding x, which means I'm going to try to figure out what is x equal when f of x, in other words, when y equals negative 487, or when the output is negative 487. So I go to my equation. This is f of x. I'm going to replace f of x, or the output, with negative 487, and then solve for x from here. So again, I'm going to be doing inverse operations. So I subtract 13 from both sides. When I do that, that adds to be 0. So I'm left with negative 5x squared equals, what is that, negative 500. Divide by negative 5. I have to isolate what's being squared, and only the x is being squared. So now this is 100. And I'm thinking, what squared is 100? Well, in my head, I might know that 10 squared is 100. So I could just write x equals 10. But if I'm not sure, I could punch in my calculator square root of 100, and it says 10. What I need to do, though, is be able to reason through that 10 is not the only number that when I square it, I get 100. Negative 10 is as well. So I can write my answer like this, or if I want to write it in a shorter manner, I could write it like plus or minus 10. And that's number 2. Excuse me. Let's get over here to number 3. Number 3 says find the x-intercepts. Well, I'm looking at this and I'm thinking, well, this is quadratic. This will be a parabola. So the parabola could have x-intercepts. So it could have 0, 1, or 2. To find the x-intercept, we've done this a lot of different ways. You could use a graphing calculator, go to y equals, and we could type in the equation in the graphing calculator. 4 minus 1/4 times x minus 5 squared. And then I can go to the graph, and we can try and see where does this graph have x-intercepts. And what we can see is that it'll have 2 out of these 2. And I can try and count these. I could also look at the table, and we know that our x-intercepts in the table is whenever y is 0. And what I see is that I have 1, 0, and there's got to be another one. Oh, there's our vertex. So on the other side of the vertex, there's the other one, 9, 0. So I could use a graphing calculator to kind of reason through that. But let's look through here and say, how can I do it without using a graphing calculator? Because I may not have a graphing calculator to do these problems at home or on the quiz. So what I remember is that in order to find x-intercepts, I know that y has to be 0. So I take this equation, I make y equals 0, and now I solve for x. I continue to do inverse operations to isolate what's being squared. This time what's being squared is this expression right here. So I'm going to subtract 4 from both sides. I get -4 is equal to -1/4 times x minus 5 squared. To get rid of the 1/4, there's a couple different ways to do this. I'm going to multiply by the reciprocal on both sides. -4/1. Any number times its reciprocal is 1, so those divide out to be 1 or multiply out to be 1. Over here, I could put that over 1. -4/1 times -4/1 is just a positive 16/1. I'm just going to write it as 16. And now I've isolated what's being squared. So in order to get closer to the x, I need to continue to do inverse operations. So I'm going to square root both sides. That gets rid of the square root, or the squaring over here, so I'm left with x minus 5. On this side, I have plus or minus 4, because 4 squared is 16 and -4 squared is 16. So again, this becomes kind of like our absolute value equations, where x minus 5 is either equal to 4 or x minus 5 is equal to -4. Those are the two options. So now if I add 5 to both sides, I get x equals 9. Add 5 to both sides here, I get x equals 1. And those are my solutions to the equation. If I write them as an ordered pair, I would write them like this, since it's asking for x-intercepts. And there you go. So that's 3 different ways I can ask you to solve a quadratic equation. If you flip to the back, we are now being asked to write an equation for the table. So in order to write an equation, I first have to figure out what family is this. So I look at the pattern in the x values, and I see that we're increasing by 1 each time. When I look at the y values, I first decrease by 12, then decrease by 4, then increase by 4, then increase by 12, then increase by 20. So what I see is that I'm decreasing and then increasing, but not at a constant rate. And so when that happens, I know that this is going to be quadratic. If this was absolute value, where we decrease and increase, all of these first differences would be the same. So now I'm looking at the second difference. I increase by 8, increase by 8, increase by 8, and what I can see is that that second difference is a common second difference, meaning it's the same each time. So this is definitely quadratic. In order to write a quadratic equation, I first need to find this very special point, and that point is the vertex. So here is my vertex. Because we're symmetrical about that vertex, so it's where we're changing from decreasing to increasing. So I know in my equation, I'll have y equals, in the parentheses, I'll have x, because that's a -2, will be opposite, plus 2. Keep the sign for the y coordinate, there you go. But I'm not done yet. I still need to figure out what that number out front will be that we're multiplying by, and to do that, I figure out what the second difference is, and I divide it by 2. So this number out here will end up being 4. So there's my equation. So if I were to graph this, the vertex would be -2, -3. The parabola would be opening up, the positive value, so we'd have this graph right here. And now it's asking me for the axis of symmetry. And my axis of symmetry will go right down the middle of that graph. That's where we're symmetrical about. So I go boop, 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 boop. I got to figure out what the equation of that line is. Well, if this is the point, -2, -3, and this is a vertical line going through that point, every point on this line will have an x coordinate of -2, so the equation of that line is x equals -2. If you wanted to, you could also do the domain and range. The domain, because the graph goes on forever to the left and right, would be all real numbers. The range, if we're talking about the y values, the graph has a minimum, that minimum y value is negative 3, so all the y values are negative 3 or greater than that. So there would be my range. There you go.